vacuole صح small vacuole صح cytoplasm يعني هذا cytoplasm
So then all affect the cytoplasm. There is no mitochondria. It's all cytoplasm. I did this, and I did this, and I did this.
What is the outer covering of
I'm
plant
not
cell?
here, I'm here.
Back. What is the outer covering of this plant wall?
Cell wall.
And this cell wall في plant.
Yes, you said the cell wall outer covering. Cell wall is the outer
What
covering.
is the cell wall made up of?
Cellulose.
Name kind of plasticide found on the plant.
Chloroplast.
Yes. What is in the center of the plant cell?
Nucleus.
What is the function of some? لا plant cell شوفها it's not the center
Vacuole.
large vacuole. What is the function of centrosome?
I don't know. I didn't
Control
study.
the growth of the cell. What's found only in the plant cell?
In the plant cell.
Talk Titi. Miss Khaled.
What's the question?
What's found in only the plant cell?
Chloroplast and cell wall.
Select the structure found in both plant and cell.
Select structure from the both
Plant and animal.
Oh, I know. Okay. For both plants and animal, they all get mitochondria.
Yes. What plant needs cell wall? What do plant cell need cell wall?
Why do plant cell need cell wall? To protect what gets in and out.
To control the movement food inside the cell.
Okay, now tell me what's
What
this
is
and
it?
this? What's this and this? They are both cell membrane.
شو مكتوبة هنا؟ شو مكتوبة هنا؟
Protect the cell from injury and hold the shape of the cell.
وين السيل وول؟
I don't know. This both of them are cell wall.
لا الثاني شو هي control?
What come in and out of the cell?
Coming out of the cell is the cell membrane. It's wrong بالواحد. Be inside. والأول واحدة شو هي؟
Cell wall.
ليش cell wall؟ ليش هي؟
Because they protect the cell from injury and they give the shape of the cell.
هو give the shape of the cell. cell wall موجودة عندك هاي هاي شفت الورقة الخميس؟
Yes.
بعدين شو هو السيل وول؟
Boss.
شو هو
What? Cell wall in plant cell.
شو هو؟
It's rigid and tough. It protects and gives this thing its shape.
and support the cell. Cell membrane.
Cell membrane found in both. It's thin outer covering. It supports the cell. Protect the cell.
نعتمد support.
Okay, let me continue. Protect the cell. Perform passive cell and transport.
عنده passive active transport and passive active and
passive transport.
He has two.
Moves molecule in and out.
The cell. بعدين
what?
the cytoplasm.
Cytoplasm like foster contains what mainly water contains supports the organelle. What's found in both? Nucleus acts like the brain of the control all cells activities. It's a big dark spot. What's this?
Ball shape. Ball.
Contain what? DNA, yes.
Nuclear membrane.
Nuclear membrane. It protects its big dark spot. It protects the nucleus.
Who's this?
Who's what? It protects the nucleus.
But it's cover the nucleus. It's thin cover nucleus.
thing that covers
والنيوكليولاس
والnucleolus. Oh, okay, nucleolus. The nucleolus, it protects the nucleus.
it's a small dark area in the nucleus. It's round. فوسط النيوكليولاس
This is nucleus.
This is nucleus, yes. وinside the nucleus شو هي؟ اقرأ.
Nucleus.
nucleolus.
Nucleolus.
الرايبوزوم. من هي الرايبوزوم؟ شو هي الرايبوزوم؟
Okay, yeah. Show me ribosome. This ribosome.
شبه
The
الرايبوزوم.
nucleoprotein.
شبه الرايبوزوم. يجيب نقاط
Small dots.
specks
Small specks in
Made
the
of
cell made
RNA.
of RNA. It produces protein.
make protein make
protein.
هو مصنع للبروتين. ميتوكوندريا
Mitochondria. It supports the cell. No. Powerhouse of the cell.
supplies
Used to make
energy.
ATP and found in both.
Location in the cytoplasm like bean shape.
Like bean shape.
Vacuole.
Vacuole. Vacuole. Yes, vacuole. Fluid space enclosed by a membrane. They store water and food tank for the cell.
Chloroplast.
Make the plants green. Function capture sunlight for photosynthesis. Mama found in plants. Okay, next.
بس الحرام أول سمحهم.
Okay. Cell wall rigid top made of cellular substance for the cell, found only in plants. In a thin covering and protects the cell perform activity, transport and passage. Found in both cytoplasm, cellular substance that contain organelles. Control over the cell activity found in both nuclear membrane. It covers the nucleus and will function. It protects the nucleus found in both. When ribosome contain of RNA, it makes protein found in both. Next, mitochondria location. Mitochondria location, and it's in the cytoplasm. It's bean shaped. When function, it makes protein found in both. Mama. Well, we have mitochondria. No, I mean vacuole. Large open storage, food tank for the food. Found in both. When chloroplast, green structure that contain chlorophyll. Used to capture sunlight for photosynthesis. Found in plants.
cellular.
Organisms that contain only one cell.
Multicellular. Made up.
Made up of only one cell.
Multicellular.
Made up of many cells.
Organism made up
Many cells.
many cells. اوكي نمشي لي لذوقا اقراني وين السيل وول وين السيل ممبرين اخر هنا واتس ذس سيل وول سيل ممبرين هذيك شو
Vacuole.
هذه شو
Nucleus.
لا هذه
Nucleus.
الثاني
Nucleolus. I cannot understand this thing. Chloroplast mitochondria.
كوندريلا كده وهذيك كلوروبلاست وهذه كتير واحد شو اسمها
Bacteria.
جولجي لا اسمها جولجي بادي
Golgi body.
والنقاط
Ribosome.
وذي سموث اي ار وذي ريجيد اي ار
Smooth ER. Rigid ER. Cytoplasm.
سيل وول
Cell wall. Cell membrane. Lysosome. Nucleus.
اسمها ليزوزوم هنا ما فهمش ليزوزوم ما فهمش ليزوزوم
كوليسترول ميتوكوندريا جولجي بادي
جولجي
رايبوزوم
اسمها جولجي
جولجي واسمه سيعار رافايلارا والسيتوبلازم والسنتروم.
سنتروم.
It has centrum.
شفت باش نعطيكم تيست غدوة عندك بيولوجي باش نقراوها زادة باش نجيبلكم تيست اللي تعمل. باهي هات البيولوجي هات المورال. عندك بيولوجي؟
No.
ها ويني؟ مال شو أول حصة؟
Oh yes, we have biology and Arabic and English and moral.
Yeah.
I will take my stuff.
جيب العربية عندك بكرة لا.
Moral. English. Where did I keep English? Where is English? Okay, I'll take my Arabic. This? Okay, what is that? One of my file.
هجيب معك الإملاء. العطلة الصيفية أضيف
Azaitu.
عطلة
Atlata.
الصيفي
Asaifi.
الماضي
Allahu.
في قرية صغيرة توافرت فيها كل أسباب التسلية
What is this layer? تاء مفتوحة.
مغلوقة اسم والسرور فتمتعت لا فتمتعت أنا تمتعت تاء مفتوحة أنا
اوكي.
بإقامتي فيها وكثيرا
Why Mrs. Mustard?
ما خرجت وقت الأصيل
وقتها تاء مفتوحة صح؟ وقت
أتمشى.
الأصيل. أتمشى
في الطريق الزراعي أماجد ظهرك ووجه بطنها تحت الأشجار الباسقة
شنو باسقتين؟
يعني طويلة
تاء
الباس
مفتوح.
ومغلوق وبين الحقول
الناظرة.
مغلقة لأنها اسم اكتب ترى توافرت التسلية
تاء مغلوق.
أيوة فتمتعت
تاء مفتوح.
صحيت خرجت
تاء مفتوح.
صحيت وقت
تاء مفتوح.
صحيت الباسقة
تاء مفتوح. مفتوح هي جمع.
الأشجار الباسقة ليش هو مكتوبة
لسه
لما
بستعمل
جمع
كده.
لما يكون مساحات فراشات قبلها مد لكن مكتوبة الباسقة قابس
أوكي.
الناظرة قبل التاء تماما مفيش مد. هز. ترجعها بكرة الصبح مش بالإنجليزي. لا.
I put the file here so you can.
Okay. جيب لي المات نحطوها في سليمات.
Me?
جيب لي المات في سليمات. كتاب المات والفيزيكس مع الفيزيكس.
Physics, push the physics.
Good evening. Hello. Hi, Gretchen. Why there is absence today? Even they are here at my home. Hello, Yemen. How are you? Where is Saif? Yeah, Saif Hassan. You will not join today? And also Fatma Wissam didn't join. Okay. What we did last time, we talked about the extraction of metal. I'm asking about Saif Amin. Saif Amin, I know you are there, but I'm asking about your friend from your school. Okay, let's see what we say about extraction of metal. We will finalize this chapter today. Hopefully you understood what we talked about. Last time we talked about the reactivity series, where a question about the reactivity series, it is very, very simple. And also you can memorize it easily, all right? You can memorize this reactivity series easily. As we said, we start from group 1 and the group 2, group 3, 4, and then transition method. So easily you can memorize this element regarding if you get a question about it in your exam. So first two elements, they are group number 1, they are the most reactive element. You may look at this direction because I explain on that. All right. So I have here potassium or sodium on the top of the reactivity series. This from group number 1. All right. And then next we get group number 2 and so on. What we said, we can find metal can displace the other one from any salt. So they will ask your opinion about this reaction. Okay, I don't know what happened to the pen. Right, so we have here this one, it's group number 1, and this group number 2, and this group number 3, and 4, and then transition method, all right? Again, they will give you just simple equation about any of these two elements, one of them in a compound. So if, for example, if I have here a magnesium and aluminium oxide, immediately you see aluminium kicked out. They will ask you what's your opinion about this reaction. I get aluminium alone free from oxygen and magnesium takes its place. What is this kind of reaction? It's called displacement reaction. What is the meaning of displacement? More reactive metal displace a less reactive one. It takes its place. All right? So simple the question. I didn't explain this table yet, but we explained the extraction of iron. You get a lot of question about that. Inshallah, we'll start to solve. I think, it is not about extraction of metals homework. It will be about atomic structure, bonding, and the rate energetic. These 4 chapters important, very important, easy. You can get a full mark about them. All right, and next we'll do this part. And I need, after that, your opinion, what chapter you want to continue. We may continue electrolysis or organics, redox, this stuff. Later on, after we finish past paper work. Okay, a name of the ore, it is a question. A formula of the hematite, it is a question. A name of this formula, also it is a question. So you have 3 questions in this line. Okay, with this question you may see in your final exam. All right, Then extraction, we have here first material, coke. Coke, you have to write down these two equations, please, important. And equation always balance. If you have difficulty in any part, please let me know. We will revise, we solve the questions until you go to the final exam, you solve the question easy. All right? And then next equation, so we have here two equations. And next one, I will explain this kind of reaction. Carbon monoxide formed here in the second step removes the oxygen. What's the meaning of removing the oxygen? Reduces the hematite. Reduces, it works as reducing agent. All right? So we will talk about this reaction. Well, please study equation in a balanced way, please. All right? Then we talked about purification. Purification from what? From excess carbon. Excess carbon easy to be removed because if you didn't remove, it will affect the property of my product. The most important property, it will not be metal, it will be more non-metal. What do you mean? Malleability will be minimum. So I need this malleability to shape it, all right? So a high percentage of carbon, it is dangerous. I need to reduce this amount because I need my metal to be malleable, all right? So minimum amount, it's 1% only, okay? If you leave a higher amount of carbon, it will be brittle or hard. Hard, that means you can't shape it. If you try to shape it, it will break. So we don't need this property. How to do that? So simple. That is a sentence. Well, please just support your answer with an equation. Always write down full answer to get a full mark. You can get high star, inshallah. All right? So we get here a carbon dioxide as a waste product. We will not, we will use it for other use. Next impurity is sand or is SiO2. What we have here, limestone, dissociate. What is the meaning of dissociation, Yusuf? It breaks down. I have one rock, I get two parts. That's the meaning. Thermal decomposition. We have one part in our air and water chapter about thermal decomposition of some compound. So this material will break down to calcium oxide, carbon dioxide. Important, very important. You may get one question in paper 2. Why you add the limestone? To purify or for purification of the steel or iron. And then you support again this important equation. I think you understand now why it is acid-base reaction, Yemen. Why this reaction, it is acid-base reaction or neutralization. What kind of oxide we have here, Yemen? This is a metal, and this one, it is non-metal. I explained that last time in the extraction of aluminum. Minna, why it is neutralization reaction or acid-base reaction? Minna? Yes, excellent. Calcium oxide, because it is metal, what we call the about basic oxide. With silicon 4 oxide here, it is acidic oxide. Acidic oxide and basic oxide neutralize each other. You get that? They will ask this kind of reaction. I wrote it here, all right? So, because explained the kind of oxide last time, right? El metal, they form a basic oxide, and the SiO2 is non-metal, it is acidic oxide. Acidic and basic, so neutralization occurs. Okay? Get any Omar, تعال. Then what we have here, I have 3 kinds of, you close the door يا يوسف لما دخلت. You close the door. يلا hurry up you mister. Then, last part here, what kind of steel we have? What is the meaning of steel? Yusuf over here, he said he get a quiz and they ask him what is the meaning of steel. Steel, it is not iron. Steel is iron plus. Remove the mask and answer me. It is made of iron and maximum percent, just we have some percent of carbon. That is the meaning of steel. I'm not talking about stainless steel. I'm talking about steel. All right? So the steel, it is made very good. It is made of iron and the carbon. And then I wrote here the function of coke, why you add coke. And we talked about the rust, the factor that causing rust. These two factors, water and air, and both should be available together. If we prevent one of them, rust will never happen. All right? Well, that's what we do in rust prevention. I need to prevent one of these factors, either by painting and bridges or oil fill in the bicycle for the chain of the bicycle. Alloying, you get a lot of question here. I said this repeated in print out. So, the definition of an alloy, it's over here. Well, how to make an alloy of stainless steel by adding nickel and chromium. Please study. We will do maybe fast work this 2-3 months, and that's it. We finish chemistry, inshallah, before the end of December. What we do next? Solving whole past paper from A to Z. This way, everybody gets a star, inshallah, but you study. I'm explaining whatever you want. I repeat, we solve a question, we do quizzes until it will be a piece of cake, the exam, inshallah. So a diagram of an alloy, you have to make one particle smaller than the other. This give what? Give stronger alloys than each metal alone. This also another question, okay? And uses of stainless steel, please memorize it. And we talked about electroplating. I didn't explain it in details. I will explain when we study electrolysis. Sacrificial protection here, yeah, Angie, is important question. What they mean by sacrificial protection, yeah, Angie? I have here this pipeline, Angie. There is any delay in my voice? Angie. Yes, your answer, miss. Your answer quickly. I need to start the other part. What is the meaning of sacrificial protection? That's one technique to prevent the rust. For example, I have this pipeline. I will put, excellent. Minna answered, I will cover this pipeline or any other object with what? More reactive metal. The more reactive metal we use, it is what? Zinc or magnesium. Excellent. We just check reactivity here. This is the main concept. The main concept, I have metal more reactive than our steel or iron. So zinc most probably we use it more than in magnesium even. Yes. One of them, because they are available and cheap. We have also economic factor here. All right. So a zinc is more reactive. What it will do? It reacts with the oxygen and no more oxygen for the iron. With this way, the iron is protected. Simple way. Very simple. Okay. If you go, I told you, if you go to Mina area, you see boat or oil rig. An oil rig, it carries expensive equipment. You see this oil rig or even boat, all right? What they do? This oil rig, it is already, we have water, air, and impurities, everything causes rust. Well, it is made from an iron. What they do? They just attach here a piece of zinc of magnesium. So simple as that. What will happen? A zinc is more reactive than the iron. Zinc on the top of the iron in the reactive series. So I have an oxygen here. Which one will go faster? Is zinc. So it keep my object, whatever, it will be protected. Yalla. Yeah, that's why I said I will explain it after we do redox, because you will not understand without an explanation what's the meaning of oxidation reduction, or maybe you have an idea from lower grade. Okay, next one we talked about the aluminium, the name of the ore, formula of the ore, and we set a purification first. And for the O level, that's what you need to know only. We have an aluminium oxide, it is amphoteric. Amphoteric, what's the meaning of amphoteric, Joanna? What they mean? If they said this oxide, it's amphoteric. Very good. It reacts. Now Angie answered. Okay. Okay, thank you, Joanna. It reacts with both, either acid or base. All right. So I have here impurities, acidic oxide. I have basic oxide. I need to remove this one. So basic oxide, all right? And I add base. Base and the base, what they do? Repel each other, no reaction, so simple. So this part remain in the bottom of the container and they separate. Well, I told you I added this just sentence. If you want to read it, they bubble carbon dioxide, which is acidic. So which part here will not react? Sand, SiO2, because it is acidic. Acidic, no reaction, and then we get the aluminum oxide. We do electrolysis. What is the electrolysis here? I said we have heavy chapter. Don't worry, I will explain it in full details. But here, because of the aluminum, I have a container, just container. If it's complicated for you, forget it. I just have a container. Well, I have rod from a graphite, where a lining of this one also, it is graphite. This part, it is negative terminal of the dry cell. It is a negative terminal. It's called cathode area. Cathode, negative terminal, it's called cathode area. Well, positive particle, it's called anode area. This we'll study in more details later on. Let's talk about the material here we place in the container. It will cover the electrodes as you see. All right? What we have, I have a mixture of aluminum oxide. I need to get this ionic compound to be good conductor of electricity. When an ionic can conduct electricity, ionic in molten or aqueous, very good, yeah, Yusuf. So this material, it will be broken to aluminum +3, all right, and oxide -2. Clear? They found that in the melting point very, very high, it will cost a lot of money. They found that by addition of another material, it will be helpful. It acts like a catalyst, but don't say it's catalyst. Don't say that. It is just material. It will help to decrease the melting point of aluminum oxide. Well, please, I'm sorry for that. Memorize the value. From 2000 to 900 degrees Celsius. Or to 1000, not different than that. So these two values, please, with the units study. So if now it is broken at lower temperature and also act as dissolve it and increases electrical conductivity. Why we add cryolite? It is important question in your exam. You will see past paper very soon about the extraction method. Once I say, just I write down this sign or I say question, that means it's a frequent question in your exam. 2 parts. Aluminium ion, let's do it here. I have 2 parts and you have to know how to write down each equation. Okay? I have this electrode, it's what? It's a negative. I have this electrode, it is a positive. All right? I have already aluminum oxide, it is ionic compound. I have here ionic compound. All right? If I break it, what I get? Let's see. Aluminium in group 3, ya Layla. So what's the charge? It is Al +3. This sign on the left-hand side or the right-hand side, no problem. Amen. You see? Metal first, positive. Always metal positive, always. In non-metal, oxygen, it's group number 6. What's the charge? -2, very good. So we have now these 2 particles because already it is melted. In molten state, I have ions. Ions are free to move now. We talked about the electrical conductivity of ionic compound. All right? So I have now positive ion, ya Fatima, and negative ion. We said before regarding the bonding, opposite charged particles attract each other, right? So where the aluminum will go, ya Fatima? I have this called cathode, all right? And this one anode. Where the aluminum, Fatima? The aluminum ion will go where? Cathode area. All right? They may ask you reason because simply the opposite charge attract, the same charge repel. All right? I have positive and negative. So this particle will go toward the cathode area. Next question is what? Writing half ionic equation at cathode. All right? Let's write it together. Aluminium at cathode area, which is a negative terminal, what we get? Al positive 3 plus. How many electrons? 3. Very good. You write down the 3 electrons. What we get? We get aluminium in molten state. What's the meaning of molten? It flow like water. So they make window frames, they make whatever object they like. Exactly. All right? You understand this equation, Omar? Yusuf, everybody is good?
Yes.
All right. Sorry? It is good. We'll talk about electrical conductivity when we talk about electrolysis in details. But this ions, if you fix here, but in this electrolysis will not put light bulb. Okay, I just show here positive and negative terminal, but later on, if we have this sign of battery, maybe we have small lamp here. So we see this lamp lighted up during the electrolysis. We'll explain that due to the movement of electron, but I don't like to confuse you now. Okay, just to understand the extraction of aluminum. Where the oxide ion will go, Omar, O negative 2, where it will go? Have a look. Aluminium gun to the anode area, positive, negative will be attracted. So simple. Once you understand this point, it is easy to explain, to describe what is going on. All right, let's write down the equation. Thank you, Angie. It's the right answer. At anode area, what is the anode area? It is a positive sign. Which particle?
Oxygen.
I will do the same way.
It will attract the negative
Sorry.
area because oxygen تي خلاص والكاثود it will attract the aluminum.
We did plus. I will do the same way. We do also same way in the exam. You will get a full mark and you never forget. Negative, how many electron? What is this? 2, very good. But we get O. Oxygen always diatomic.
Oxygen it's diatomic, she said since last time.
So I have 2.
And we have 2 there.
With 2 in front of the ion, please. Never under the ion. Okay, now the electron, how many?
4.
Balanced. It's balanced.
4, very good.
So put 4 here.
If you want to write down this electron on the right-hand side, up to you. Either one, accept. Next part, we talked about it, that we get another gas here formed, carbon dioxide, because of formation of oxygen, where? Around the anode. It is very frequent question in your exam. All right? Then we talked about the property and use. This first property, very frequent question in your exam. It is light, low density. So what do we have on the sky? Aeroplane. I need my aeroplane to fly easily. So they make a body of aeroplane. So aircraft body, because it is low density. All right? Then el cable, not a wire. We'll talk today about the wire. This, it is the cross section of area of a cable. It is very thick. I have el core. It is from an iron because it is very strong. Even the iron also, it's got conductor, but it is yes. So this core, because of the strength, aluminum got conductor of electricity, and the last layer, it is insulation plastics when we studied plastic, or polymer. I will explain this part more. And we have other uses, you may read it, but we have also from your exams, the frequent question, what? About the food container or the window and door frames. Because of what? It resists the corrosion, never rust. All of us, we have these windows years and years, okay? It is from aluminum, I can't reach, okay? Because of this property, right? And also you may write down, because we use it for food container, due to presence of what? If we leave this aluminum in air, what we get? Natural layer, non-toxic. Of what you use? Aluminum oxide, very good. I have one layer. It is not rust. It is not like an iron. We get this layer of aluminum oxide formed, all right? But it is non-toxic, so we can use even pot from aluminum, all right? We can use it in the kitchen.
Yes.
Even an aluminum foil, if you leave it for a while, you see just layer, but it is not toxic, all right? So we use it for the food container. You see this question a lot, and also window and door frames, because it resists corrosion. Let's see, to finalize this chapter is zinc and the copper. Zinc and the copper, very, very similar, way easy. Let's see. I will explain both together. I have here zinc and the copper. We'll talk also about the name of ore of each one. We start with the zinc. I have here copper. A name of the ore of a zinc, it's called zinc blend. Zinc blend, please memorize. Zinc blend, that's the last two metals in this chapter. Well, in fact, it is heavy chapter in our syllabus. All right, zinc blend. A name of the ore, zinc blend. El copper, it's called malachite or malachite. We write it down there. This is very rare question for el copper, or in name of its ore. Right? Very good, Yejuan. So el zinc, it has this name, zinc blend. It is made of what? I will write down the formula. Please pay attention. ZNS. This, it's called zinc sulfide. Sulfide, like oxide, like nitride, like chloride, like bromide. So this one is called zinc sulfide. So the chemical name, it is zinc sulfide. It is zinc, one element, with sulfur, one element. Just attach it to each other. All right? The name of the ore again, zinc blend. Malachite or malachite, it's made of what? Either copper carbonate or copper hydroxide. Or, very good, Yejuan. Copper carbonate or copper hydroxide. I'm sorry, we have a lot of formula now, but that is the last. After that, we will revise some part from chemical calculation. I said before, the calculation, I will not do it in one lesson, but every class, we do one kind of question. Today, we'll talk about the rules of the calculation you need. It is easy chapter. Once you follow the procedure of the calculation, it will be very simple. Okay, again, I repeat. El zinc, el name of the ore, zinc blend. El name of the ore of copper, malachite. A zinc blend, it is ZNS, which is zinc sulfide. With this one, copper carbonate or copper hydroxide. Why I do explanation for both together? Because same way. First step, it is roasting. What is the meaning of roasting? Anyone? Very good, Yusuf. Heating with air, with hot air. Also, copper, roasting. All right? Roasting. As you roast your bread in the morning, what you do if you want to eat, especially in the weekend, not during the week. Okay. No, we use the hot air, Juan. So we heat our bread in the morning in the microwave or in an oven, or even if we have time on the grill. So roasting. Okay? Roasting, it means heating. Very good. Heating with hot air. All right? So, air plus heating. That is the meaning of roasting. All right? Let's see what we get. Please pay attention. The name of the formula of the roast of zinc, it's what? It is ZNS. Zinc وsulfur. What is the active part يا عمر in air? Oxygen, very good. I have O2 here. Pay attention, please, to understand what we get from this roasting. Very good, Joanna. I will separate a zinc blend to understand only, but when you write down the equation, you don't need to do these steps. Sulfur alone with zinc alone, all right? Well, oxygen same way, O and O, all right? Sulfur with the oxygen, we get sulfur dioxide. We don't have SO2 in our air. We get sulfur dioxide. We balance the equation, of course. We will work on the balance. I know you ask Yomer for the balance, and maybe other student also will do balancing. But let's just pay attention about the extraction. And what about the zinc? With O, with the other O, we get ZNO. Okay, so simple. So roasting, we get zinc oxide and sulfur dioxide. Oh, please balance the equation. We will, again, we'll do balance together later on. All right? Then, let's do the same for el copper. But in case of copper, we will not adding oxygen. It is just same equation we did for calcium carbonate. I will do copper carbonate here. It breaks down to give what? Exactly, assume this calcium. We did that in the iron. قول يا حبيبي يلا يوسف. Oxide, very good, and CO2. That's it. That's it. We get copper oxide and carbon dioxide. Okay, again, I repeat, you need to study, to memorize some work a little bit. Again, inshallah, we will finalize the explanation by December or before the end of December, بإذن الله. So don't worry, just try to work harder in chemistry because you will see it is the first subject to finish. All right? So we get copper oxide and carbon dioxide. Again, I repeat, first step for either extraction of copper or zinc, roasting. What's the meaning of roasting? Supplying hot air. Hot air. It is a source of energy, source of heat energy, all right? In case of a roasting of copper carbonate, please don't add oxygen. We just break it down exactly like thermal decomposition. It will give copper oxide alone and carbon dioxide, as we did with a limestone in the extraction of an iron. All right. I have one important question here. Then we continue. The uses of sulfur dioxide. The uses of sulfur dioxide. This waste product, but it has important use in our life. It is what? When you eat this preserved food, canned food, okay? How to keep this food for 1 year? If you keep it for 1 week out of the fridge, what will happen? The bacteria damage it, right? Excellent. It will kill the bacteria or germ. So please avoid eating any canned food, any preserved food, because you will study later on this sulfur dioxide. It is used for manufacturing sulfuric acid. Imagine you eating here sulfuric acid. It is harmful. Eat fresh food, okay? So one important use of sulfur dioxide to keep our food preserved as a preservative for the food. This chips you eat, potatoes or any fruit or vegetable, or even sometimes meat or this stuff, it is preserved the food for longer time. How it works? Just kill a germ. It's killing germ. What else? How to make a paper? It's from what? This paper, our paper, from what? From what we get the paper? Tree, very good. What's the color of tree? They take this trunk, el brown, not el green, ya Joanna. They will not cut the green part. They take this brown part of the tree. Yes, el wood, yes, from tree. Okay, it's called bulb. Okay, very good, Yemenna. So we have this dark, they add chemicals, so we get what? Bulb. It's like a dough, but it is dark. If you try to write down on this dark paper, you can't. So I need it to be white like this board. How they do that? By adding sulfur dioxide, it acts as a bleaching agent. What's the meaning bleaching? Remove this dark color. All right? This just question here between the extraction. It is frequent. So if you get question here about state 1 or 2 uses of sulfur dioxide, I repeat again, as a food preservative, if they ask how it works, by killing in germ. Clear? And as a bleaching agent for wood bulb. Wood bulb, they get the wood, this wood from the trees, okay? They cut and they put chemicals. It is not our problem, okay? Okay, Yasif. Okay, Habibi. Yeah. If you attend last lesson, so you may go now. I don't remember because you are changing the group from time to time. You may leave, Yasif. Okay, Habibi.
Bye, Mister.
Okay, Bob. This is why Sif Amin didn't join. All right, so we have here 2 uses of sulfur dioxide. I don't, let's check if I wrote it here or in the manufacture of sulfuric acid, maybe. Anyway, I will add here to the note and I send to you. All right? So we get back now to extraction again. First step, it is what? Roasting. Roasting by supplying hot air. We get zinc oxide and sulfur dioxide, and we ask one question here about that. So we get uses of sulfur dioxide. All right, I have a zinc oxide. I need to remove the oxygen. How to do that? From very good, ya Yusuf. Next step for both. Here I get copper oxide from the roasting also. I get zinc oxide from the roasting of zinc blend. All right? So what we do to remove the oxygen? Reduction. First step roasting, and next step reduction. Next step reduction. Let us do it together. It is exactly similar to reduction of iron oxide. So next step reduction for both metals. Reduction, for the moment, the reduction, yes, exactly, we can say coke or even carbon monoxide. I will give you 2 choices. You can write down both options. So next step again here for copper, reduction. So roasting and the reduction. I have here zinc oxide. If we add coke or even carbon monoxide, it is exactly same reaction. What is our goal? Removal of this one. And removal of the oxygen from a zinc oxide. In either case, we get our metal plus a carbon dioxide. But in each case, you have to check the balance of the equation again. All right? I repeat again this part. Roasting, what we get? ZNS plus O2. Roasting of copper carbonate, no need to add the O2. In both cases, we get metal oxide. We get copper oxide and zinc oxide. Next step, I need to remove the oxygen. How to do that? Reduction. It's called the reduction by removal of oxygen. When I explain the redox, inshallah, maybe after. I will talk about it. Just wait. All right? So, reduction. It is up to you. You may add coke, which is C, or CO. Both acceptable. But when I write C or when I write CO, It is mandatory sometimes. What you mean? If they said solid reducing agent, Solcock, it is solid. If they say gaseous reducing agent, so CO. We will see this kind of question. Don't worry, no need to make it complicated now.
gas.
Let's do the same way for copper oxide. What I add? Copper oxide plus C, what we get? We get my metal here, copper and carbon dioxide. Well, of course, we balance, coke. Or you want to write down this equation with carbon monoxide, you can do that. So CuO plus CO, what we get? Same. We get our copper plus CO2. It is just a matter of how to balance each equation. Up to you, both acceptable. Again, first step roasting, next step reduction. We get the metal, yes, but unfortunately, the metal we get, it is impure. What is the meaning of impure?
Mixed.
Exactly. It has another material we don't like to be there. It will affect the property. Yes, exactly. So next step, it is purification. Removal of impurity, purification. So next step, number 3, I will explain it, but the equation, I will do it in the electrolysis. Purification or refine. Purification. Purification or refining. I need to remove impurities. All right? So roasting, reduction, purification. How to do that? Please pay attention. Again, container, anode, which it is the big sign. I attach here what? Ugly shape, which it is impure metal. Impure metal at anode. Impure zinc. At cathode, small sign, very thin layer of pure zinc. Any metal. We can do it for any metal. All right? The negative terminal here, it is cathode. I will not write down the equation. I will explain this part in electrolysis chapter. You see it in another page. Where show me. Yes, it is a small sign, pure metal. Well, anode, maybe the shape is not very clear here. You see, this very positive with thin layer as negative. All right. So you have in the material, in the node, you get different diagrams. I will explain what is going on regarding this part in electrolysis, inshallah. So purification, how to do that? Impure metal at anode area. Please study that. All right. And pure, we fix very thin layer, very thin. All right. We same if you do for copper. Again, this is copper. If we can put an anode on the other side, no problem. But be careful, that is a positive sign. That means anode. That is the ugly shape. It means it has impurities. All right. Well, cathode is what? It is this one. I fix very thin layer of what? Pure copper. Pure copper. All right. What I quoted here, I cover it with electrolyte. It is any metal, nitrate or sulfate. Also, this I will explain when we do electrolysis. Okay. What will happen in this process if you check a note? I have here a diagram. After a while, we will see what? You see an anode dissolves. What is the meaning? Impurities remain here. You see the cathode area, which is a negative. It was thin. What happened after? Exactly, get thick. That means the mass of cathode with the time increases because the copper, the pure metal, it is deposited here at this area. I will explain how this happened. How this happened. But I wrote for you here, impure anode dissolves, as you see. This very good diagram to show what is going on. Where is the impurities? It is settled down here as called sludge, but also you don't need to know that. The impurities will settle down in the bottom of the container, all right? And by the end, we get pure metal. It may be silver, it may be gold, it may be any metal. This separate question, how to purify any metal by electrolysis. Inshallah, I will revise this. I will explain it, not revision. I will explain it with the equation and observation and the question about it when we start electrolysis. So we have 3 steps for both material, copper and zinc, roasting and reduction and purification. So simple. What is the meaning of roasting here? That is the equation, balanced equation. Please study. 2 marks in your exam. 2 marks. They will ask, write down or how to do roasting by supplying hot air, and they will ask you to write down an equation. Then, next question, how to get the zinc from zinc oxide? By what? Reduction. It is over here. That's the equation of reduction. It is so interesting if you will work as an engineer in this production. Really, it is interesting. Once you understand the concept, it is really interesting. And last step, purification. Again, just understand for the moment, we fix impure metal here as positive terminal, which is anode. All right? And pure, and that is diagram better one. Pure, very thin layer from pure one, and then that is the net result. Impurities start to dissolve and you get a pure metal here deposited at cathode. You will understand this later. But just for the moment, we fix impure at where? At anode. We fix impure at anode. All right? But again, all this, it will be done later on. Let's talk about the uses. Where zinc? We talked about alloy of stainless steel. We have alloy of zinc. Very frequent question in your exam. We have this alloy, it's called the brass. It is a mixture of copper and zinc. So both metals, they mix together, they mix. We get this important alloy. They will ask you, brass, it is made of what? What is the component of brass? I'm sorry again for the memorizing. Copper and zinc. All right? So by adding some of zinc and copper, we get this an alloy. It's called brass. And we talked about sacrificial protection today. All right? So zinc is used for sacrificial protection. What else? We have here dry cell casing. We saw this battery or dry cell before, right? I will show you where is this zinc. It is this material, okay? It is a casing, okay? This outer, we have chemicals inside. Let's show them also, okay, Shabab? We have important use for zinc. What is this use? You see this dry cell or a battery? You see this side, it is the anode. We talked about it before. Okay? You see positive sign on this. It is the anode area. And this side, it is a negative. It's called cathode area. This material, the casing of this, it's called the dry cell. Wrongly, we said it's battery, but it is not battery. A battery only in the car. But this dry cell casing, see, but this material here, it's clear. You see this color? It is a zinc. What is the question here regarding use? They will ask to state down or to write down 2 uses of zinc. Sacrificial protection important, dry cell casing also important, or alloy. Either 2. But study 3 of them, please. All right? Now we understand the uses of zinc. Let's seal copper. Anyone get a piece of scrap of wire? if you open any wire, this is the wire connected to the computer or TV or whatever. So the metal here for the copper, it is used for what? For a wire, small wire. We sold cable before. What is a cable? Cable, another story. It is made of iron, aluminum, and plastic. A wire, this is small wire. Don't touch, of course, or don't cut the wire if it's connected. If you have one piece of scrap, you find this wire, it is from copper. What's the color of copper, by the way? Very good, reddish brown or pink. They will ask about it, okay? And also you may study, or you study physics, right? So it is circuit. Any circuit you do, it is, you see spots, yes. It's better to say brown, yeah, Joanne, okay? Brown or reddish brown, accept. Okay, and also in alloy, we have two alloys here contains the copper. Please memorize by heart. We talked about the brass, which is copper and zinc. Well, bronze, it's copper and tin. Important, important. They will ask about either one. El bronze made of what? Complete the sentence for 2 marks. You can get it. We'll study, we'll do some homework, we'll do past paper later on. We'll solve all the past paper from UK, from USA, from India, from Middle East, until you get used about how to answer full paper proper. All right? And so if you go to Emirate Palace, you see a tap to get the water. It is from copper. Copper, it is expensive. Our homes, it is other metal, less expensive, all right? It may be from certain kind of iron or nickel or whatever. But this expensive taps or pipes, hot water pipes, it is made from copper in luxury houses, all right? So you may write down also for hot water pipe. And some people like to get copper kitchenware. It is also very good because it's good conductor of heat. It's a metal, okay? You have a lot of uses here for copper. The most important one, a wire, will 2 kinds of alloys here, all right? So we talked about the uses of each one. We finish the extraction of metal, except an explanation of purification by electrolysis, also electroplate. Please, if you have a question, ask. If you have any question regarding this part, ask. Yalla habib. If you have a question, don't be shy to ask. I like to help myself, in fact. No? You don't have a question? Think about it. If you have a question while I'm explaining, just write it down and then ask. Okay, el alloy, it is what? El alloy, again, I need to mix 2 metals together. 2 metals, all right? Assume. I have this metal and this metal. Now I get an alloy. So at least 2 different metals. We can mix by hand. Okay, we mix it by hand, so it's an alloy. All right? Then, el drawing, you have to know how to draw. We didn't revise the state of matter yet. We said we draw 1 big size metal and 1 small size metal too. All right? Just we draw this particle closely packed, and it is not 50%, 50%. Okay? My drawing is bad. In this way, small and big, we get stronger metal than either one, because the difference here inside this, good question. Okay, this small size, it prevents the layer from sliding. We still get malleable alloy, but it is strong. This is why stainless steel very, very strong, very strong. So we have here different alloy in this chapter, right? It's what? We saw alloy of stainless steel. How to do that? I have an iron, where it has a small percentage of carbon, this already there. What we do? I add two other metals, just memorize them. Chromium, Cr, and nickel, Nr. That's it. Or you write down the name of each one. That is in manufacturing of stainless steel. All right? For zinc and the copper, we have here different kind of alloy, very, very important.
زنك and copper.
Brass or bronze.
brass with
Where's this brass? In your key. If you have your key of your home, some keys, you can find it from brass. It is expensive. They mix copper with zinc. They mix here copper with zinc. Not all of them. I didn't do it yet, Joanna. I didn't do the electrolysis. I didn't do the electrolysis of to purify metal. I said I will do it when I explain electrolysis. You will not understand it now. Just keep this part until I finish electrolysis, inshallah. But just understand that we fix impure metal at anode with very thin layer at cathode من البيور. So here one alloy is called the brass. All right? Memorize copper with zinc. We have another one, bronze. Where? Coins. Or our coins. Okay? El coins, it is made from el bronze. Just memorizing that we mix metal together. Take your time to study this chapter. Really, it is interesting. Again, I didn't explain the purification. I didn't explain electroplating to prevent the rust. I didn't explain the first table here. Because again, it is based when I explain electrolysis, immediately you will understand. There is something mandatory before that. So please study what we finished. And after we finish, I will send tonight homework about the bonding, atomic structure, and the rate will energetic. It is part of grade 9, but it's important. If you understand to solve all these questions or this chapter, it's very good. We're still in September. We didn't finish 1 month here. All right, so we are doing very well. Let's start with this chapter of calculation. Calculation, we have different rules. Chemical calculation, why we do calculation? Chemical calculation, I need to find mass of material produced. I need to find formula. I need to find volume of gas. I need to find concentration of solution, and so on. So I will start again to talk about this chapter gradually. What do you mean? Every class we do one kind of question. Today we'll talk about the rules needed. What is the rules needed in the calculation? All right? Let's see. If you feel cold, you may switch an AC less cold if you feel. All right? We have here a periodic table. We talked about an atomic structure. I need to understand what is the atomic mass for any element here. For example, I have oxygen. Oxygen, it is 816. Omar, what is the atomic mass here? What is the atomic mass? What is the mass of this atom? 8 or 16?
16.
16, the higher value.
God, we took
The
this
higher
before
value.
this.
It's called the relative atomic mass. It is called AR. We saw that in the atomic structure chapter. We will do question, inshallah, if next class about that. Also, if you get any element like iron, Fe, I have 26 and 50, what is that value? Iron 56. All right? So a higher value, it is a relative atomic mass. All right? We need it. So I will talk now about the first rule. We will use it in the calculation. What is this rule? If you have a mass of a material, if we have mass of material, what is the unit of the mass, Yanada? Normal. What is the less than kg? What is the other unit? Gram. Very good. Gram. Okay? So if you have solid material, we have a certain mass, it should be in gram. Of course, we have kilogram. How to measure the mass? Like, what is the apparatus we use to measure the mass? When you go to buy tomato or fruit, balance. So balance, it is used to measure the mass, all right? So we have this rule, okay? I have M, what is this M? الماس in gram. الماس in gram. Important. We never use any other unit in calculation of الماس. In gram. Maybe very rare they give you ton or kilogram, but never happen in IG of Cambridge. That's a yes, they give them different units. For you, we have el mass in gram, it will be given. I have here in this side N. What is N? Mole. What is this mole, ya miss? It is amount of material in this unit. Also amount. Okay? Just to understand the units or a rule, and we'll practice question now. I have here in this side either AR or MR. What is the AR? A relative atomic mass. For example, the sodium, if I write down the sodium, 11 and the 23, what is the mass of this atom? It is 23. It is this value. It's called AR. In most cases, it's given in the question, but you have to know how to find it in the periodic table for whatever element. Okay? Now, to calculate the amount of material in mole, we divide here the mass over the AR for one element, and then we talk about what is the meaning of MR. All right? So a number of mole of whatever material equal M in gram over what? Over the AR, if I'm talking about
I know this, yeah. I
one
know this
atom.
معلوم. Very
Let's
perfectly.
practice.
I have
Let's
known
practice.
Very nice.
So, for example, if I have
this very carefully.
2.3 grams of sodium, I need to find a number of mole. I substitute in this rule.
اكتب
How
N.
to find it? N over AR.
23 على 2.3.
What is the AR for sodium? 23. So simply, I divide here at 2.3 gram over at 23. What we get? We get 0.1. What is the unit? Mole. Mole. Just I'm explaining the rules. We have different kind of question later on. Okay? Again, I repeat, you have mass in gram and you have an AR in the periodic table. It is known value. An AR, it is known value for all of you. Well, periodic table, it is given in any chemistry exam or quiz. If they didn't give, don't start to solve. Ask for the periodic table nicely. All right? Don't start to solve. All right? So this, it is statement attached to your exam paper, whatever, quiz even in 10 marks. Next, if I have a compound, what is the meaning of compound? Fatima. Compound. That is an element. What's a compound? Wake up. انت نايمة خالص today. What? Yusuf, wait. What is a compound? أنا قلت لك قبل ما نبتدي لسه هتستني معايا النهارده بقى مش رايحة بيتكم النهارده. مين اللي يقول what's a compound؟ يلا حبيبي.
It's a group of molecules joined together.
Very good. Combine together. For example, ya Miss Fatma, instead of sodium alone, okay, I write down sodium oxide. Sodium oxide. So it is a compound. I explained that in the bonding. Okay, I have sodium oxide. So I need, in this case, to calculate something called MR. What is this MR? It is molar mass,
Wait.
relative molecular mass, or formula mass. It has different name.
شارك
So
She
it's
did
called
not give
molar
the-
mass.
Did you give
All right?
mass?
A
Yeah,
mass
yeah,
of
with
1
MR
mole.
كم؟
How to calculate it?
Well, if
I
you
just
have
add. I have here 2 sodium. والصوديوم في periodic table is 23 we said. والoxygen it is 16.
23.
So what we have here to find the MR, I have 2 of a sodium, 2 times 23 plus
62.
oxygen 16. That's it. What is this value called? MR, molar mass. All right? We will practice together now how to find the MR for a different compound. Once you calculate this value, what is this value? I think it is what? Anyone has a calculator? خد يا عم. 62. It is right value يا منى? 62? Okay. Now, if I have the same mass, 2.3 gram, well, I need to find a number of mole of this compound. I will use the same rule. Where is the same rule again? M for a compound, M, and instead of an AR, it will be what? MR. So simple. Again, I repeat. For me, I call this chapter mole chapter because we need every time to find a number of mole. Thank you, Amanallah. All right? Let's see how to find the number of mole of this compound. Already we calculated the molar mass or the MR. We just substitute in the rule M in mass per gram. It is given 2.3 over MR 62, and just you get the value, and don't round in this case. We get here 0.038. What is the unit? Mole. Mole. All right? Please, always when you do calculation, you have 2 points to do. Double check. Unit. That's it. Well, by the way, calculation, it's the easier chapter plus organic. You may hear from other students, organic is hard, calculation is hard. Don't listen to anyone. Just study, solve past paper, and you will see. You will see. All right? So first rule of the calculation of a number of mole for a solid, it is what? Either in mass over an AR if we have one atom only. If we have 2 different atoms or more, or even not different, so we divide over MR. MR, that means we calculate a total number, a mass of every element in the formula. I have 2 from a sodium atom. So 2, what is this? 23. Atomic mass of sodium. Well, oxygen, it's 1, so 16. Before we go to the next rule, I need to practice together how to calculate the MR for different material. For example, simple molecule H2O. Okay? The hydrogen, it is 1 in the periodic table. Well, oxygen 16. Yalla, Aman, how to calculate this value? What is the MR of this material? Aman. Aman, you hear me? Very good. So I have 2 hydrogen atoms, so 2 times 1 from a periodic table. The hydrogen, it has this value, H11. So the atomic mass is 1. You have this value. Well, oxygen is just 1 atom, so you can add 16. Oh, please show your work in the exam. You may write down a unit. It is gram per mole. Gram per mole, if they ask. But it is, they will not reduce and mark for you if you didn't write a unit in this case. If I have this material ينادى calcium hydroxide, okay? El calcium, it is 40 from the periodic table. Well, oxygen 16. Well, hydrogen 1. If you have 2 here in the bottom of the bracket, so exactly you have to multiply all material between in the brackets by 2. Very good. So tell me what I write down.
Yes.
40 first, 40 alone, plus
70 times 2.
a 2 before the bracket. That is the best way. What we have in the bracket?
Do something else called
16 plus 1. That's it.
70, 70,
You can do this way,
You're
and
right, you're
that is a better way.
We use
Okay.
something else called
I just tell you I'm engineer. I'm a chemical engineer. So I'm giving you mathematic way. It's easy for you. So I have 44 calcium from a periodic
Told you.
table
I use
and
this, I
2
never use
from
this.
the bottom of
I
the
never use
bracket,
all teachers
and then whatever element in the bracket. That is the best way. So this 17 multiply by 2, and then you add to this one, it is 74. Very good. Let's see this formula. Let's see this formula. Copper sulfate dot 5 parts of water.
Full 250.
If I ask here, Joanna, what's the meaning of dot in calculation? What is the meaning of dot in calculation?
It's hydrated.
No, it's a calculation. I don't need the explain. I know it's hydrated salt. What I do when I get an MR for this material? What is a dot?
What is the dot?
Addition.
No answer? Yes, excellent. Amen, amen, only answer. No, ya Minna. Minna, you forgot.
Addition.
El dot in math, it is multiply. But in chemistry, addition. Add. It is a question even in grade 12. That's why I practice with you. Repeat again. A dot, any formula, you have this dot. That's mean, as you said, it's hydrated salt. So el copper, it is 64 from a periodic table. With this 132. Well, oxygen we saw before, it is 16. El hydrogen is 1. Well, oxygen we know. So what I do now, 64 plus 32 plus 4 times 16. It may be a question for 2 marks. They will ask you to calculate the molar mass of this material. Plus, you see this plus? Big plus. 5. Then the water between bracket 2 plus 16. You see the value, it will be 250, almost. Right? So we get here the MR of copper sulfate, and it's a frequent question in your exam. Even grade 11, they get this question last year. Find the MR of copper sulfate dot 5 parts of water. That is the way. So dot in chemistry, it is addition. We get here 250. That is the MR. Clear? Okay. So we talked today about if you get a mass of material. We will practice, don't worry, just we do a refreshment. A calculation, it is easy. There is no memorize. Okay? Just you do what? Every rule, just understand what is this M and what is the AR, what is MR, and what is N. We substitute. If I need to get a number of mole, we divide the mass over the AR or the MR for a compound. All right? Now, if I have a gaseous material, it is more easy than this one. Much easier. But let's see if you have a gaseous material. What is the rule? I have the same triangle. I have a volume of gas here in decimeter cube. A unit for a volume in decimeter cube. All right? A volume, always it should be in decimeter cube. If you get a volume in cubic centimeter, how to convert it? Anyone has an idea? Divide by 1,000. Very good, Joanna Womenna. Yes, yes. I divide here by 1,000 if a volume it is given in cubic centimeter. Always it should be in decimeter cube. Clear? Now I have here an N, which it is what? A mole. And we have here 24, it is a molar volume. It is constant, just it will be given in the question, don't worry. And you will get used about that by solving a question from a past paper. All right? Now, the volume of any gas equal N times 24. We get L units always in decimeter cube. All right? Or if they need a number of mole, we do division. Number of mole, we divide L volume in decimeter cube, please. All right, be careful about this one. Over a 24, you get a number of mole of the gaseous material. Let's practice. Let's do simple example.
To make it in decimeter of 2.
You don't have any condition here, Yejwana, regarding this part until you go to higher level. We have ideal gas according to the condition. All right? So assume I have this value, this volume, cubic centimeter of fluorine gas. I need to find its number of mole.
You will change it to
What is the
decimeter,
first
divide
step?
على-
Very good. I convert the volume we have. Instead of cubic centimeter, I need it to be what? Decimeter cube. How to do that?
300
By
decimeter
dividing
cube.
over
لا 300 decimeter
1000. Very good. So first step, the volume given equal. Please show your work in the exam. I divide by 1000, so we get here 300 decimeter cube. 300 decimeter cube. Now you are in the safe side because you have a right unit. Next step, what I do to get a number of mole? Divide over 24. You substitute in this rule. I need to get a number of mole by dividing the volume over 24. So N equal 300 over 24. You get a number of mole, of course, and you get high value. In fact, usually we get small value, but no problem. I just explaining what you have to do. So we get here a number of mole of the gas. Easy question about a gaseous material. Next one, if we have solution. What is this solution? Hydrochloric acid solution or sodium hydroxide solution. He will tell you in the question, we have a solution. All right? What is this rule? Pay attention, please. I have here this rule again. The number of mole of the solution equal CV. CV, what is the C? It is a concentration. Very good, Yusuf. Will V always decimeter cube el volume? As exactly, I remind my student, when you go to apply for a job later on, you need your CV. So you get a number of mole of any solution by what? Just you multiply concentration times the volume. The concentration times the volume. So N equals CV. Again, the volume always in decimeter cube. All right? Let's do an example. For example, I have here a number of mole. It's given 0.25 mole of hydrochloric acid. Its volume given, it is 300 cubic centimeter. What I do for this cubic centimeter,
خليني أركز.
if I need to find, exactly, we divide by 1000 to get it in decimeter cube. Because I need to find the concentration. You will use the same rule. The concentration equal what? Equal N over volume. This sign, N over volume. So the concentration. Before we substitute in the rule, I will convert first L unit. I just divide this one by to get what? 0.3 decimeter cube. Now we are in the safe side. The concentration equal what? Equal N over volume. We have a volume. Yes. The concentration. We have a number of mole already given, 0.25 over 0.3. Let's see unit. What is the N? It is mole. N, it is mole. Okay? What is the volume? Decimeter cube. So once you do this division, you get the value. 0. What is the unit? You see? Mole per decimeter cube. Mole per decimeter cube. That is the unit. Mole per decimeter cube. I repeat again this rule. If you have solution, that means we have volume of solution. Please always check that the volume either given in decimeter cube. If it is given in cubic centimeter, just divide by 1000. Easy step. So you are converted the volume to the right one, to the right unit, and you need to find the concentration. For example, if they give you a number of mole, just divide. That's it. Okay? We have also another rule. Now it is officially in your IG exam. It is what? Using Avogadro's constant. I will say this rule and that's it. I know you are tired, all of you. I know. Me too. Okay, that's the last part. I'm sorry, just 2-3 minutes. I have last rule to use what? Avogadro's constant. What is this Avogadro's constant? No, 6.02. It will be given in the question. What it means? Very good, Yejwan. I have here a number of what? We will calculate either molecule or atom. It is called particle. I have n times something called Avogadro's constant. It is very big value. What is this big value? 6.02 times 10 to power 23.
I told you.
Right?
I
That
told
is
you.
called the Avogadro's constant.
Times 10 to
This,
power
inshallah, we'll
24.
practice next time.
Avogadro.
I will start with this part.
I learned.
How to find a number of molecules
Number
or
of the
atoms.
moles in a mole
If you
of
check a
atom
note of the
in a
chemical
mole.
calculation,
يساوي
I didn't
number
do
of the
the
atoms
parts
times
in order. I just
Avogadro's
explained
constant.
only rules. Here, that is the rule
You see?
of if you have a mass in gram, how to use it, how to calculate the MR, that's the rule of the mass. All right? And I talked about, we didn't get any kind of question yet. Next time, inshallah, maybe we'll start with empirical formula or a number of the particle, as I said, using Avogadro's constant. And then that's the rule for a solution. Only rules. Only study rules, please. Just revise. If you are studying daily, yeah, and this is the volume of the gas. All right? Thank you. See you, inshallah, next lesson. Just wait, please, 1 second. I will send homework. Please try to solve it. What is your next lesson? Monday. That's good. You have enough time. It's about atomic structure, bonding, and the rate will energy. Revise this 4th chapter and finish. It's study. And then we solve some homework. Of course, I will explain every question and its answer. All right? Thank you, Shabab. See you, inshallah, next lesson. Bye-bye. Bye. Omar, if you want to stay to explain البالانس or next time يكون early أحسن مرة تانية إن شاء الله.